Hello children, I am your chemistry teacher. In this video, you are going to study the second part of the chapter 9, carbon. And the learning objectives of the topics of the chapter are the charcoals and some useful properties of carbon. So dear children, let's begin. The charcoals. Charcoals are prepared by a process known as destructive distillation or pyrolysis. In destructive distillation, a substance is heated in the absence of air with a view to breaking bigger molecules into smaller ones. So the other name of destructive distillation is pyrolysis, and this process is using for preparing charcoals. During the process, certain substances distill out and may be collected. Wood charcoal, then activated charcoal, bone or animal charcoal, sugar charcoal, lamp black, coke, and gas carbon. So let's look at what are the topics are mentioned here. Wood charcoal. Wood charcoal is prepared by the process of destructive distillation of wood. A mixture of gases and vapors evolves in this process, and charcoal is left as a residue. The mixture of gases is combustible and is known as wood gas. On being condensed, the vapors separate into a tar and a liquid, and the liquid is known as pyroligneous acid, and this contains some organic compounds. And the mixture of gases also mentioned here: carbon dioxide, carbon monoxide, and like that. So now we are going to discuss about the destructive distillation of wood, and the destructive distillation of wood can be carried out on a small scale in the laboratory. So that is going to be explained as in the form of an activity. Look at the figure. So you can make wood charcoal at home also. Put some wood shavings in a can and cover it with a lid. Make a hole in the lid and heat the can on a stove. So this is showing in this figure. Hold a lighted match to the mixture of gases that's emerging from the hole, and it should burn with a steady flame. Look at the figure that's showing, and place a can full of ice near the hole, and substances in the mixture that have a low melting point will condense around this can, and turn off the stove. Then when the gases will be stopped evolving, and examine the cans after they have cooled, then the wood shavings would have converted into the form of charcoal, and there will be tar on the surface of the second can as well as on the inside surface of the first. So this is the activity is explaining that the destructive distillation of wood. Then, being a form of carbon, wood charcoal shows the general properties of carbon, which we will study in higher classes. So, wood charcoal and the related with activity is over now. The next is activated charcoal. Activated charcoal, that is prepared by heating wood charcoal at a 900 degrees Celsius, and that is in a limited supply of air or steam. So any tar in the wood charcoal is removed and the surface area of the charcoal will be increases. Then next is bone or animal charcoal. Animal bones are first boiled with the water, then remove fatty substances, and then subjected to destructive distillation in a retort. The solid product in the retort is washed thoroughly with the hydrochloric acid, and the residual substance is bone charcoal. So this is the way that bone charcoal is formed. The next is sugar charcoal. Sugar charcoal is the purest form of carbon, and it is prepared by the process of destructive distillation of cane sugar or by the dehydration of sugar with the concentrated sulfuric acid. Then next is the lamp black, and the other name of lamp black is soot. When substances like oil and wax burn, then the soot will given out. Then the last one is coke. Second last one is coke. Coke is obtained when coal is heated strongly in the absence of air. Coke is more porous and therefore more active than coal. The last one is gas carbon. Gas carbon deposits on the walls of retort when a hydrocarbon is heated in it in the absence of air. So gas carbon is a good conductor of electricity and is therefore used as an electrode. The next topic is some useful properties of carbon. And we have already discussed some properties and uses of different forms of carbon. So let us talk about a few more of its properties and its uses. First one is adsorption. Adsorption is a physical property, and you have learned that in adsorption, a thin layer of substance is formed on the surface of another substance. A thin layer of substance is formed on the surface of another substance. And a substance on the surface of which adsorption takes place is called adsorbent. Then, adsorption is a surface phenomenon in which a thin layer of the adsorbed substances is formed. Then, for example, moisture is adsorbed at any solid surface that is exposed to moist air. The formation of a thin film of oil over the surface of water is another example of adsorption. So these are the two examples. First one is moisture is adsorbed at any solid surface that is exposed to moist air, and the formation of a thin film on oil over the surface of water is another example of adsorption. Being a surface phenomenon, adsorption is dependent on surface area, and it is found that the larger surface area of the adsorbent, the greater is the adsorption. So the next topic is adsorption by charcoals. As charcoals have a large surface area in powder form, they are good adsorbents. The following uses of charcoals are based on this property. Look at that. What are the following uses? 5 uses are mentioned here. The first one is wood charcoal is a good adsorbent of gases. It is therefore, this is used in gas masks to remove poisonous gases. An active form of charcoal prepared from coconut shells is especially suitable for gas mask. So the second one, bone charcoal, that means animal charcoal, is used to remove the brown impurities from the unrefined sugar. And the third one, many impurities of water are removed by filtration through charcoal. And this is done in municipal water treatment plants as well as in domestic ultraviolet purifiers. Then the fourth one is activated coconut charcoal is used for separating a mixture of noble gases. Noble gases means helium, neon, argon, krypton, and xenon. So the different noble gases are absorbed by the charcoal at different temperatures. And activated charcoal facilitates certain chemical reactions. This is the fourth use. And therefore, this is used as a catalyst. For example, chlorine is adsorbed on activated charcoal and readily combines with hydrogen. It darkens. The reaction between chlorine and hydrogen in darkness is otherwise extremely slow. Then the last topic of this video is this, the chemical properties and their uses. First one is a reaction with oxygen or air. On being lit, carbon burns in an excess of oxygen or air to form carbon dioxide. Then next is a reducing properties. Carbon has a great affinity for oxygen, so it combines with the oxygen present in many compounds and thus act as a reducing agent. And the next one is a reduction of metal oxides. When heated with coke or charcoal, the oxides of metals below aluminum in the activity series, for example, zinc, iron, tin, lead, and copper, are reduced to the corresponding metals. And the metals is also mentioned there. And this kind of reduction called a carbon reduction and is of a great importance in metallurgy and the science of extracting metals from their ores and modifying them for use. So the last chemical property is this, the reduction of water. When steam is passed over red hot coke, a mixture of carbon monoxide and hydrogen is formed, and this mixture is called a water gas. So water gas is a great industrial, we know that water gas is of great industrial importance. So children, I'm going to winding up this video. Thank you.